Okay, for now we are done with part A, but you need to create plots for each of the maps, including north arrow, scale, and title block. For all of these, you can go back to previous lab where Tyler completely explained how to create the plots. Okay, next we want to rank all the different interpolation methods. For this purpose, because we have kriging included in that and we didn't do kriging, or we didn't create variograms for thickness of the 3 stratas, so first go to the data and create different variograms based on thickness now. So I'll show one and you should pause after that and create the 2 others yourself. So go to Strata Calc and calculate variogram 2D, select all the drill hole data, enter. Now I'll show you the soil data, so go back. So before you selected elevation, now we wanted thickness based off feet. Select that one. So now we want semi-variogram. To see this data, you can change the number of lags as much that you can see the data in the way that you can fit any of these models. Because right now you don't want to compare spherical, exponential, and Gaussian together. So you just need one kriging model based off best of these. What I mean that you change number of lag and distance as much to be able to feed any of them, and whichever fits better, you just save that one, and that would be the kriging variogram for that strata. That's it. So right now I will change this to 20 and then make this to 85 and this to 42 and graph change it to 10 and 75, 35 and 36 and graph. Alright, so now I think the distance is not covering the whole area. Changing to 350. Okay, and 125. And the graph, so it's, I make it 300 and 150 and graph, it looks fine. And I think I make the nugget of 20 or 25 to match the nugget, and if I spherical data of 25 like this, I think that's a good match. I'll call this, so then I'll save this and I will name it soil kriging, and it's based off spherical and thickness, and save. And because I already had one, so I will replace it for you. So same thing you need to do for saprolite and limestone. So exit out of this, right click, repeat calculate variogram 2D, select everything and do it for saprolite. Next time you want to do the same thing for limestone. Now you can pause and create those two variograms. Next, after you prepare those, we want to compare all those based on residuals. So it means the difference between the calculation and actual points. So how we want to do that? So go to Strata Calc and auto run residuals. Click on that. We want to select all the drill holes integers and alright. So first we want to add strata to process. So it would be soil based on thickness. So 1, 2, 3, 4, 5, 6, 7. So you choose each of them one by one. So I first do it based off triangulation, soil thickness, and click OK. And next, I want to add soil thickness inverse distance. Click OK. Next, soil thickness kriging and set kriging parameters. Load. It's for soil kriging, so it will set it automatically. Click OK and OK. So next it would be okay. So instead of doing all these one by one like this, so you can select all these 3 layers, click OK, click thickness, and use type of triangulation, choose strata. Oh, we already did that, which is 3 of them. Click OK. And so it's soil, thickness, all the strata, based of triangulation. Click OK. So it will add all the soils once. All the soil, limestone, and saprolite based off triangulation. So to show it again, I remove or I'll clear the data. So add, choose a strata, all these 3, because we want everything based off thickness. First triangulation, click OK. So I have soil saprolite based off triangulation. Next, add, choose a strata, soil again. Oh, sorry. Add, choose a strata, all 3, click, thickness, based off inverse distance, all 3. Again, add, choose a strata, all 3, click OK, thickness, kriging. Now it will ask for variogram. So we want load for soil first, click OK, load for saprolite next, click OK, load for limestone next, load and click OK, and then click OK. So you have soil, sap, and limestone. If you have doubts about that, you can anytime click on each of them and edit to make sure you have correct file. And then next I want to add base of polynomial, so choose strata all three, click OK, thickness, polynomial, and it will be power of 2, so I don't change anything, click OK, and next again add, choose all three, click OK, thickness, and least square, power of 2, it's okay, and I have those, add ABOS, choose all three, thickness, click OK, next is choose all three, thickness, and nearest neighbor, and click OK. So I have all of them, they're saved, and you can now check if everything is fine and click on, you can save this file and calculate residuals. So it will process. Okay, make sure to have use report formatter on before calculating residuals because it will export everything into Excel. So then you click calculate residuals. Okay, now that you have report formatter options, we can have all this or just the absolute value residual, but we'll add all of the available data in the use, and you can go to any MS Excel or import export and export to Excel. And make sure it be here. Residuals. Okay. And save. Okay, so now if I go to the folder, I have the residuals. Okay, so now we want to convert this value, so you can make a table out of this and check it for soil first. Okay, so since that the lowest residual based on my data, so for sure these values for your calculation would be different because where you have your boundary, what you define as a nugget HCl is different. So if I see in your report that you have the same numbers as me, it seems that you cheated. So don't make sure that you have unique values. Okay, so right now I can say, for example, for soil, the best method is inverse distance based off power of 2. And for limestone, the best method is a bus. Okay, so decide those ones, and then based off that, we want to create geologic model. Okay, how we do that? So let's go to the question. So it says that, so right now, based off that, so you create maps. So you, based off the grid files, because the grid files are already saved, you create for each of the best one, for the limestone stratum, you, for example, for ABOS, you create, for thickness of that, you create a grid based on the thickness, and you'll make a plot out of this. So you'll do this part, and then we'll move to the fence diagram. Alright,